The volt amps per square foot table found within Article 220 of the National Electrical Code, or NEC, is exclusively designated for service calculations. Its purpose is to estimate the overall electrical load a building's service, meaning the main electrical supply, must handle, not to dictate the limitations of individual branch circuits within that building. Therefore, the idea that a 15 amp circuit within a dwelling is inherently restricted to serving only 600 square feet based on a 3 volt amps per square foot calculation is a misapplication of the code. A 15 amp 120 volts branch circuit has a capacity of 1800 volt amps calculated by multiplying the amperage 15 amps by the voltage 120 volts. This capacity dictates the total load that can be safely connected to the circuit, not the physical area it serves. For branch circuits in dwellings, the primary consideration is the total load connected to the circuit, ensuring it does not exceed the circuit's capacity of 1800 volt amps for a 15 amp 120 volt circuit. This load can be comprised of lighting fixtures, receptacles powering various appliances, or any other electrical device. The NEC provides specific guidelines and tables to calculate the load contributed by each of these elements. For example, each general use receptacle outlet is typically calculated at 180 volt amps unless the actual load is known to be higher. Lighting loads are calculated based on the type and wattage of the installed fixtures. Appliances, either portable or fixed, are considered at their nameplate rating, representing the maximum power they consume. The key is to sum up all these individual loads and ensure the total does not surpass the 1800 volt amps limit for a 15 amp circuit. When dealing with continuous loads, which are loads expected to operate for 3 hours or more, it's crucial to apply the 80% rule. This rule mandates that the maximum continuous load on a branch circuit should not exceed 80% of the circuit's rating. For a 15 amp circuit, this translates to a maximum continuous load of 12 amps calculated as 15 amps multiplied by 0.8. This is because the NEC allows overcurrent protection devices, such as circuit breakers, to be loaded to 100% of their rating for non-continuous loads, but only 80% for continuous loads to prevent overheating and potential fire hazards. Applying the 80% rule to the 1800 volt amps capacity means that for continuous loads, the maximum allowable volt amps is 1440, calculated as 1800 volt amps multiplied by 0.8. Understanding the distinction between branch circuit load calculations and service calculations is fundamental for electrical installations. Branch circuit calculations focus on the individual circuits within a building, ensuring they are adequately sized to handle the expected load without exceeding their capacity. Service calculations, on the other hand, determine the overall electrical demand of the building, which is used to size the service entrance conductors, the overcurrent protection device, and the transformer, if applicable. The volt amps per square foot method in Article 220 is a simplified approach to estimate the general lighting and receptacle load for a building when the actual load is not known. This method assigns a standard volt amps per square foot value based on the building's occupancy type, such as dwellings, offices, or retail spaces. For dwellings, the NEC typically specifies 3 volt amps per square foot for general lighting and receptacles. This means that for every square foot of living space, an electrical load of 3 volt amps is assumed. This value is then multiplied by the total square footage of the dwelling to arrive at an estimated total volt amps load for lighting and receptacles. Other loads, such as appliances, heating, ventilation, and air conditioning systems, are calculated separately and added to the general lighting and receptacle load to determine the total service load. For example, if a dwelling has a total square footage of 2,000 square feet, the general lighting and receptacle load would be 6,000 volt amps, calculated as 2,000 square feet multiplied by 3 volt amps per square foot. This value is then used in conjunction with other load calculations to determine the total service load and subsequently size the service equipment. It's important to note that the volt amps per square foot method is a minimum requirement, and in many cases, the actual load may be higher, especially in modern homes with numerous electronic devices and appliances. In such cases, it's crucial to perform a more detailed load calculation based on the actual connected load to ensure the service is adequately sized. Misinterpreting the volt-amps per square foot table and applying it to branch circuit calculations can lead to undersized circuits and potential safety hazards. It's crucial to understand the intended application of each article and table within the NEC and apply them accordingly. Branch circuit calculations should always be based on the actual or estimated load connected to the circuit, considering factors such as continuous loads, receptacle outlets, lighting fixtures, and appliances. Service calculations, on the other hand, should be based on the overall electrical demand of the building, considering factors such as square footage, occupancy type, and the connected load of various systems and equipment. In summary, a 15-amp circuit in a dwelling is not limited to 600 square feet based on the volt-amps per square foot table in Article 220. This table is exclusively used for service calculations. Branch circuit calculations should be based on the actual or estimated load connected to the circuit, ensuring it does not exceed the circuit's capacity and considering the 80% rule for continuous loads. Understanding these distinctions is essential for safe and compliant electrical installations. Let's delve deeper into the specific considerations for branch circuit load calculations, focusing on the different types of loads encountered in a typical dwelling. Firstly, lighting loads are a significant component of the overall branch circuit load. The NEC provides specific requirements for calculating lighting loads based on the type and wattage of the fixtures installed. For incandescent lighting, the wattage rating of the fixture is used directly in the calculation. For fluorescent and LED lighting, the ballast or driver input wattage is used, as this represents the actual power consumed by the fixture. In addition to the fixture wattage, it's also important to consider the number of fixtures connected to the circuit. Each fixture contributes to the total lighting load, and the sum of all fixture wattages must be within the circuit's capacity. Furthermore, the NEC requires that lighting loads be calculated at 100% of their rating, meaning that no demand factor is allowed. This ensures that the circuit is capable of handling the full lighting load at any given time. Secondly, receptacle outlets are another major contributor to branch circuit loads. The NEC specifies a minimum volt-amps value for each general use receptacle outlet, typically 180 volt-amps per outlet. This value is based on the assumption that each receptacle outlet may be used to power a variety of appliances and devices, and it provides a safety margin to ensure the circuit is not overloaded. The 180 volt-amps per outlet rule applies to all general use receptacle outlets, regardless of whether they are single, duplex, or multiple receptacles. Each outlet is counted as a separate load of 180 volt-amps. For specific appliances or devices that are known to have a high power consumption, such as refrigerators or washing machines, the actual nameplate rating of the appliance should be used instead of the 180 volt-amps per outlet rule. Thirdly, appliance loads are a diverse category that includes a wide range of electrical devices, from small kitchen appliances to large home entertainment systems. The NEC requires that appliance loads be calculated based on their nameplate rating, which is the maximum power consumption specified by the manufacturer. The nameplate rating is typically expressed in watts or volt-amps, and it represents the maximum power the appliance can draw under normal operating conditions. For portable appliances, such as toasters or blenders, the nameplate rating is used directly in the load calculation. For fixed appliances, such as dishwashers or water heaters, a nameplate rating is also used, but additional considerations may apply. For example, the NEC may require that the circuit be sized to handle the motor starting current of the appliance, which can be significantly higher than the running current. In addition to the individual appliance loads, it's also important to consider the diversity of appliance usage. Not all appliances will be used simultaneously, and the NEC allows for demand factors to be applied to appliance loads in certain situations. A demand factor is a percentage that is applied to the total connected load to account for the fact that not all loads will be operating at the same time. A demand factor can vary depending on the type of appliance and the number of appliances connected to the circuit. Fourthly, motor loads are a special category of appliance loads that require additional considerations. Motors can draw significantly higher current during startup than during normal operation, and the starting current can overload a circuit if it is not properly sized. The NEC provides specific requirements for sizing branch circuits and overcurrent protection devices for motor loads. These requirements take into account the motor's horsepower rating, voltage, and type, as well as the starting method used. In general, the branch circuit conductors for a motor load must be sized to at least 125% of the motor's full load current rating. The overcurrent protection device must be sized to protect the motor against overload in short circuit, while also allowing the motor to start without tripping the device. The specific requirements for motor load calculations can be complex, and it's important to consult the NEC and other relevant resources for detailed guidance. Fifthly, continuous loads are loads that are expected to operate for 3 hours or more continuously. The NEC requires that continuous loads be calculated at 125% of their rating, meaning that the circuit must be sized to handle 125% of the continuous load. This requirement is intended to prevent overheating of the circuit conductors and overcurrent protection device due to prolonged operation at high current levels. For example, if a circuit is supplying a continuous load of 10 amps, the circuit conductors must be sized to handle at least 12.5 amps, calculated as 10 amps multiplied by 1.25. The overcurrent protection device must also be sized to protect the circuit conductors against overload, taking into account the continuous load requirement. In addition to the 125% rule for continuous loads, the NEC also requires that the overcurrent protection device be rated at no more than 80% of the circuit's ampacity. This requirement is intended to ensure that the overcurrent protection device will trip before the circuit conductors are overloaded, even under continuous load conditions. By considering these different types of loads and applying the appropriate calculation methods, electrical professionals can ensure that branch circuits are adequately sized to handle the expected load and operate safely. Remember that the volt-amps per square foot method in Article 220 is not applicable to branch circuit calculations, and that branch circuit calculations should always be based on the actual or estimated load connected to the circuit.